Carlos, we ready? Okay. Hi, everyone. I'm Jeff DeMoss from Red Hat AI Product Management. Welcome to the Q1 edition of our What's New, What's Next update. In this session, I'll be joined by my colleagues on the AI Product Management team to go through the latest Red Hat AI roadmap. We'll be highlighting the new features and enhancements planned for upcoming releases. For the Red Hatters joining us, please post your questions in the Slack channel listed on this slide. PMs and SMEs should be monitoring this channel throughout the session. We host these What's New, What's Next sessions quarterly, and you can find the recording and these slides after the session at the link on the screen. And then finally, as a reminder, this is a roadmap session, so forward-looking statements are subject to change. All right, with that, let's get started. Red Hat AI is our enterprise hybrid AI platform and product portfolio. It's designed to support the full AI lifecycle for both GenAI and predictive AI use cases. All Red Hat AI products support hybrid environments, public clouds, on-prem, or at the edge, as well as a variety of accelerators, including Nvidia, AMD, Intel, and more. Ultimately, our goal is to enable any agent, any model, any accelerator, and any cloud. To see how Red Hat AI translates into measurable outcomes, we recently published a Forrester Total Economic Impact study. Some of the findings include improving GPU utilization from 30 to 80%, increasing productivity by reducing model training time, accelerating projects through faster MLOps provisioning, and improving profitability through faster AI productization. You can download the study using the QR code on this slide. The Red Hat AI mission is to accelerate the development and delivery of AI solutions across hybrid cloud environments. We focused our strategy on 4 key pillars that we introduced last year. First is fast, flexible, and efficient inference. We invested significantly here last year, and we'll continue that focus this year as inference is the primary entry point for many customers. Next is connecting models to enterprise data. We're expanding our approach here with extensible modules for fine-tuning, RAG, and prompt management to improve domain-specific accuracy. Next is accelerating agentic AI deployments. We're ramping up here our investment to add new capabilities in this rapidly evolving space. And then the final pillar is the platform foundation that enables scaling and managing inference training and agent deployments across the hybrid cloud. It includes enabling use cases like model as a service and GPU as a service. We'll dive into the specific product plans for each of these pillars. The Red Hat AI portfolio is designed to meet customers wherever they are in their AI adoption journey. It includes 4 products. First, Red Hat AI Enterprise is an integrated platform for enterprises looking to deploy and scale AI models, agents, and apps efficiently and anywhere. Red Hat AI Inference Server is for enterprises that want to optimize LLM inference. OpenShift AI enables enterprises to extend the capabilities of OpenShift to support distributed AI workloads. And RHEL AI provides an out-of-the-box platform for consistently running LLMs in individual Linux server environments. So diving deeper into Red Hat AI Enterprise, which we officially introduced earlier this year, this is our comprehensive integrated platform. It combines OpenShift AI and OpenShift into a single solution for building, tuning, and deploying both GenAI and predictive AI. At the top layer, we provide tools for AI application and agent development, including model catalogs and an AI gateway for secure access to models and assets. It's supported by an inference at scale layer that handles the heavy lifting of serving models efficiently. The platform also includes the security, governance, and observability capabilities needed for production. Underpinning everything are the container and Kubernetes platform services, which manage resources across a range of hardware accelerators and infrastructure. This architecture ensures operational consistency, whether organizations are deploying in a private cloud, a sovereign cloud, or at the edge. With that, I'm going to pass it over to William.
So inference is where AI delivers business value, and enterprises need it to be fast, flexible, scalable across the enterprise infrastructure. Red Hat AI Enterprise, on the left, combines VLLM, LLMD, and model as a service on OpenShift AI across Nvidia, AMD, Google TPU hardware, and others. Red Hat AI Inference Server brings those same capabilities to the RHEL and third-party Kubernetes side. Both of these are available today. What's new is the early access of LLMD and model as a service on both products. LLMD enables disaggregated inference, scaling, prefill, and decode independently for better throughput and lower latency at enterprise scale. We know customers love OpenShift, but many also run Kubernetes on hyperscalers. The Red Hat AI Inference Servers gives them the enterprise-grade GenAI interface on their platform of their choice. One consistent stack wherever they run. Next. One of the biggest barriers to enterprise AI isn't choosing the right model. It's having the infrastructure and data foundation ready to support the enterprise AI at production scale. IBM Fusion for Red Hat AI solved this. It's a jointly engineered, factory-integrated stack of compute, storage, networking, and GPU. This is validated, tested, and brought up to all the way to on-site with white glove service. The system is operational in days, not months, and with single vendor accountability across the entire stack. You have one trusted partner for platform, storage, lifecycle management, and support. What makes this unique, powerful for AI is the data layer. Fusion provides unified block, file, and object storage with content-aware service that automatically generate rack-ready content directly from your existing enterprise storage. Your sensitive data never has to move. AI comes to the data and not the other way around. And it exposes that data through modern interfaces, including MCP, OpenAI compatible APIs, such that it plugs directly into your AI applications. On top of that, the operator-driven automation ensures consistent deployments across development, testing, and production environment, reducing the drift and operational risk. With built-in resilience and disaster recovery for AI workloads in production. IBM Fusion for Red Hat AI provides fast and trusted path for enterprise data to production. Next is the Red Hat AI Factory with Nvidia. It's a co-engineered, jointly validated platform that deeply integrates Red Hat's enterprise AI capabilities with Nvidia full accelerated computing stack. On inference, customers get LLMD, VLLM, Dynamo, and Triton. For agentic workloads, customers get a unified OpenAI compatible API surface with built-in MCP catalog, evaluations, and safety capabilities. For training, distributed training with NeMo framework alongside with the model customization pipelines from Red Hat AI. To accelerate adoption, Red Hat and Nvidia provide joint quick start and blueprints. These are validated, ready-to-run patterns that get customers to production faster. The end result is a best-of-breed AI infrastructure from two industry leaders. Fully integrated stack, day zero ready. So your teams can focus on building AI and not assembling the stack. Next, and with that, I give it to Yujin.
Thank you, William. So fast, flexible, and scalable inference, Red Hat AI Inference gives AI platform teams speed of light performance, flexibility with architecture freedom in the open ecosystem, and a production scale. As William mentioned earlier, one consistent stack wherever they run. So in the next section, we'll show you how Red Hat Inference makes this real. Next slide. So we introduced agentic AI in Red Hat AI 3. Now we see agents, reasoning models. These are massively increasing the demand, along with workload heterogeneity and shifting memory and compute patterns at every single stage. So meeting that demand really requires a holistic full stack approach to optimize and also operate AI LLMs at scale. So at the bottom of this diagram, we optimize across most popular accelerators in the market with Nvidia, AMD, Google TPU, also recently added Intel CPU, AWS Inference Server, and IBM Spark. In the middle, so VLLM is de facto inference engine. It's acting like the Rosetta Stone that map diverse accelerators to really the fast-growing new models and new architectures we see every day. And then moving up to scale a cluster of VLMs, we build LLMD, which is purpose-built for Kubernetes, because we all see vanilla Kubernetes designed for fast, cheap, uniform HTTP requests. They often breaks under the LLM workloads. And on top of everything, we have AI gateway, API management for secure and metered model as a service. So this end-to-end stack is exactly what Red Hat AI delivers, an enterprise-grade generative AI inference platform. Next slide. So now let's look at what's landing in VLM specifically, the engine that powers all of this. So on the left, what's new for 3.3 release. On the hardware side, we have B300, GB300 support, but also includes this Blackwell optimization stack, such as tuned fused kernels, give you the maximum performance out of the box. We also significantly improve ROCm while expanding to MI3 25x with Torch compile integration, optimized Triton kernels, etc. So we give the competitive throughput performance on AMD hardware. Also, we add Intel CPU, AWS Inference, Trainium, and TPU new plugins for workloads where GPUs we see are oftentimes overkill, such as embeddings and smaller models. And moving down to the model side, frontier support from latest Mistral model to Quine 3 multi-model, also plus specific niche enterprise models like BART, geospatial model families. Rob will cover Red Hat validated new models. We have a whole suite after this slide. Moving down to performance, GPT-OSS 120B is one of the most popular we see in enterprise. And we set the new Pareto frontier on Blackwell. It gives 38% more throughput, 13% better interactivity simultaneously versus the previous optimal config from Inference Max. So this is driven by Flash Infer, Torch Compile Fusion, some runtime optimizations. And also we improved DeepSeek v3.2. We cut the inter-token latency 40% on H200 compared to previous releases. On top of that, async scheduling at roughly 10% throughput out of the box. And actually, we just enabled it by default. When you combine it with pipeline parallelism, that's 30% throughput gain out of the box. Now, moving right to on the 3.4 release, looking ahead, we have a Nvidia RTX Pro extending Blackwell performance to workstations for enterprise inference without data center hardware. We also add AMD MI350, 350X, and for large-scale serving, we add KV connector support for hybrid KV cache. So for those who are curious, hybrid KV cache is the state-of-the-art attention mechanism that makes full attention and sliding window attention layers like GPT-OSS. We also expanding the wide EP support, including adapter, and then expert parallel load balancing so that we don't overload certain experts when you serve multi-mode MOE models. Speculative decoding also goes production grade, and Rob will cover more details later as we have more exciting news on speculators. Moving down to H2, we will establish Rubin Day Zero performance leadership at Red Hat and VLLM Omni. So it's one unified multi-model serving stack for text, image, video, and audio. So no more front-end stack. And performance cost optimization is a cross-layer effort with close collaboration with model optimization team. So I'll turn it to Rob Greenberg to share more model strategy and model capability optimizations. To you, Rob.
Thank you, Yuchen. So now let's take a look at the model layer of our enterprise GenAI inference stack to get a deep dive into our third-party model strategy, focusing first on third-party model validation, and then we'll talk a little bit about model optimization and all the work going on there. Next slide, please. So looking at the validated model program, which has been out since last summit, we've continued to invest in this effort, in which we take models and put them through our secure supply chain model packaging pipeline to make the models into model cars, as well as OCI artifacts. We then take those models and run them through rigorous inference performance benchmarks, as well as accuracy evals across different hardware and use cases to really give our customers confidence in deploying third-party models on the Red Hat AI platform. So in January and February, we released two distinct batches of validated models on our latest releases from them. They include a wide array of models, from models such as Apertis, which is a really big model in Europe that came out of Switzerland, and Swiss AI, also covering a lot of the new Nemotron models out of Nvidia across a wide array of compression formats. So you can see NVFP4 there, which is specifically optimized for Nvidia Blackwell GPUs, as well as different formats. So this is something we're continuing to invest in terms of model batches, which we intend to release around a monthly cadence. Coming up soon in 3.4, we will have a March batch of validated models coming out in just a few weeks. Also getting into tool calling validation. So basically validating certain models for tool calling capabilities, which really ties into our agentic capabilities and those workflows that we continue to invest in as we expand out the types of AI assets that the platform will support. Also getting into security expansion, which we'll talk a little bit about later as well. But really investing in vetting these models so that enterprises can feel confident using them from both a performance, accuracy, quality perspective, as well as a security perspective. So taking models from Hugging Face, running them through scans, ensuring that when you deploy these models, they have already been assessed for specific vulnerabilities is definitely an area we intend to invest a lot further in. In terms of what's next, we're also looking at different use cases. So expanding to speech to text, text to speech, multimodal use cases as well. Like I mentioned before, expanding up security features, and then expanding evaluations and benchmark scenarios is another key area for our validated model effort. Next slide. To highlight some of the new work landing in 3.3 for model optimization, we've continued to be focusing on compressing some of the latest LLMs landing on Hugging Face for major model providers like Mistral, Qwen, and Nvidia. Hot off the press as of last night, we have released the 0.10.0 release of LLM Compressor, which we're really excited about. This release adds significant performance improvements, including DDP support and enhanced offloading support to handle very large MOEs or mixture of expert models. You can definitely go check out the release notes linked here to see more there, or just Google LLM Compressor, and you'll find it under the VLLM project on GitHub. For 3.4, some other areas we're very excited about, as Yuchen referred to, is our plan to GA speculators within Red Hat AI Inference Server. So speculators is a unified library for building, evaluating, and storing speculative decoding algorithms for LLM inference and VLLM. So speculative decoding is an inference optimization technique that accelerates LLM inference by using a small, fast draft model to predict multiple future tokens, which the larger target model verifies in a single forward pass. This ultimately can help reduce latency and can boost throughput often 2 to 3x without sacrificing output quality. We're also expanding the variety of Eagle 3 models that we intend to provide on our Hugging Face as well as in our model catalog soon, so that we can really help commoditize speculative decoding as a go-to pathway for inference. So this is something we're really, really excited about, planned for 3.4. In terms of what's next, continuing to expand on compression formats and ML research. So looking at mixed precision and kind of different compression algorithms in that sense to really get more and more speed up out of these models. And then, like I mentioned before, expansion of speculator models and integrating those flows more natively into the rest of our products as well. I'll now pass it over to Naina to talk about distributed inference.
Thank you, Rob. So for distributed inference in our GenAI inference platform stack, LLMD is what we use to bring optimizations at the cluster level, and Kubernetes is our choice of orchestration platform. Next slide, please. For our Red Hat AI 3.3 stable release, we have upgraded LLMD to version 0.4 upstream to bring in the new features and hardening. And hardening and stability theme continue with the strict TLS for all pod-to-pod communication, which prevents lateral movement within the Kubernetes cluster. For security, our private by default model ensures that no inference endpoint is exposed to the public internet unless explicitly routed through the inference gateway. We have also added a high performance computing guide that provides the roadmap for establishing high availability production grade distributed inference environments using RHOAI. In our Q2 release, we are focusing back on features with launching distributed inference with LLMD on other Kubernetes, targeting CoreWeave and Azure Kubernetes services in phase 1. We're also adding OpenAI batch inference support, and with that, the ability to prioritize traffic to most critical workloads between real-time inference requests versus the batch job. Another feature, inference-aware autoscaling, is going to be another well-lit path where we are going beyond generic heat metrics for scaling and focus on the saturation-aware intelligence, like by monitoring KV cache usage and request shape. The idea is to prevent both performance bottlenecks and wasted spend on idle hardware. For long term, we are looking at bringing distributed KV cache offload to remote storage for expanding KV cache, multi-cluster intelligent inference routing, support for LoRa, and last but not least, picking up on various operational improvements like fault tolerance, AB, and Canary rollouts. Next slide, please. Model as a service is our AI gateway API management layer that is about empowering platform teams to offer a service that can centralized approved model endpoints and also provide the essential governance layers with features like identity, access control, rate limiting, and usage tracking. Next slide, please. With Red Hat AI 3.3, we are offering the tech preview of model as a service. And so MAS is our multi-tenant governance layer, as I was mentioning. For LLM serving, it is built specifically for the Red Hat AI ecosystem, so it acts as the intelligent front door for all model traffic. It offers token coder management to prevent cluster-wide high bandwidth memory exhaustion, API keys for AI engineers for secure identity-based access that enables usage tracking and chargeback models. It is zero-touch installation via RHOAI operator, and platform admins can navigate it through our dashboard, and developers can navigate it through our GenAI Studio. We would love for you to try it and provide us feedback and request any new features that you see fit. Next slide, please. In terms of what's next, model as a service would be generally available in Q2 with features like enhanced UI to show back usage tracking dashboard, external OIDC authentication, and flexible registration of the models by assigning metadata at the time of registering a model to MAS, as well as addition of model as a service capabilities for VLLM runtime. For a second half of 2026, we are looking at support for external models to be generally available in Q3 to 2026. And in addition, we are looking at bringing intelligent routing across different models in your environment, failover mechanism and burst capacity. So if GPU fails or a pod becomes unresponsive, the gateway can detect it and reroute the traffic to a different replica. I would also like to announce that we are running a proof of value for our GenAI inference, so we can come and work in your lab environment and show you what value it brings. So please reach out to your Red Hat contact to know more. Thank you. And with that, I'll give it back to you, Rob.
Thank you very much. So on the ML serving side in 3.3, we introduced ML Server as a GA feature along with major UI updates to help with rolling updates and recreating deployments and their associated configurations, in addition to general UI enhancements that we've done to projects, registry, and catalog pages. So ML Server will support 3 frameworks at launch: Scikit, XGBoost, and LightGBM. Coming in 3.4, we have model cache support in serving, which will enable faster restarts, so avoiding longer downtimes when auto-scaling the serving of customers' LLMs and predictive models as well. Then towards the latter half of 2026, we have a cross-functional initiative to provide hardware profile recommendations specific to the top LLMs and their use cases to ensure our customers deploy models the right way the first time. We're also looking at adding UI support for CADA to introduce scaling options into OpenShift AI natively within the UI. Next slide, please. So this is a quick look at our model catalog and some of the new validated model performance insights that we very recently released. So model performance insights really help bring all that rich data that we do for model validation and embed that right within the model catalog natively. So customers can go in, they can apply different filters to see what the benchmark results look like across different GPUs and for different use cases like chat or RAG or code fixing. And really have an easier time figuring out their capacity planning when they're determining what models they should be deploying where within their cluster. So this is a really exciting feature that we actually rolled out late last year, but very excited to continue to expand on that and improve the user experience for the validated model performance insights. Next slide. In terms of the model catalog and registry, we also are excited to, we just rolled out those hardware recommendations in there and continue to expand on that. So every release, when we land new models that are validated, we put them into the catalog and are continuously expanding that collection. We talked a little bit about model security on the model validation roadmap of an area that we're looking to invest further in. Signing and attestation is something that actually landed in the model registry in our 3.3 release, and we're looking to continue to expand on that and really start signing and attesting and showing the provenance of models from day one. So right when they go from Hugging Face through our secure supply chain, we're able to track that lineage and ensure that these models are safe and secure. We also announced a really exciting feature to connect to the catalog to Hugging Face to make models more easily available, to really expand the search space for models that customers might want to pull in if these models have not yet been validated or packaged by Red Hat ourselves. In terms of what's coming next, we are also looking to add in default PostgreSQL support, which is something we're really excited about. And then looking towards the later half of the year, we're really trying to consolidate the model catalog registry along with the validation roadmap to get more into security, signing, verification, provenance tracking, and then also AI bombs, right, to show the kind of a bill of materials of what's been packaged up in these model containers across all the libraries and everything included there to really be very transparent about our models and the lineage there. Next slide. Okay, and I'll hand it off to Jalem to talk about connecting models to data.
Awesome. Thanks a lot, Rob. So we've added a number of new features accelerated by the integration of watsonx AI. And most users, so all of these features basically are along the model customization lifecycle. Most users typically begin with prompting, uploading data in the prompt window for additional context engineering along with the prompt. Our users have likely done this with a Gemini or a ChatGPT. I know I have. And so in Red Hat AI 3.4 release at Summit, we're adding a new prompt registry and more prompt tuning capabilities within the product. We're also taking it a bit further and making it easier for you to build such applications of your own in case you have a use case to provide a RAG chatbot to internal users within the company, or a RAG application or a pipeline as a part of a larger app. We aim to make it easier for you to get started with building this. So a new auto RAG feature will allow you to automatically configure and test different RAG configurations that you can then export and just experiment more easily and see value faster. Finally, the success of any application, especially for generative AI applications, is driven with evaluations. In fact, evals very likely should be the first piece that are being defined. You need to know how you're going to measure success of what you're building. So we're adding Evaluation Hub in the product, which is our newest module, and it will allow you to run evaluations for your models through models as well as fine-tuning, RAG applications, agent evaluations, so basically throughout the lifecycle. And we'll talk about all of these exciting features in just a bit. If we can go to the next slide, I want to talk a little bit about the Python index that we continue to expand with Red Hat AI 3.3. This is a key component for us to deliver a familiar experience to data scientists, to AI engineers who want to just grab packages and start building their generative AI applications and their workflows. With our Python index, we enable that for data scientists and AI engineers while delivering peace of mind to the platform admins who can rest assured that the generative AI workflows are being built with the Red Hat builds of these Python libraries and are tested and verified for use on the platform and our product. The index provides a trusted, secure, and reliable source for the generative AI workflows, which are especially critical for air-gapped environments. The functionality, bugs, or feature requests related to individual packages will be reviewed by Red Hat and fixed. Our primary goal is basically to provide a secure and a reliable platform for developing, testing, and building models on Red Hat AI. And these packages form a key component of this platform. If we go to the next slide, I can jump quickly into the data processing side of the house. Here, our focus is on providing trusted, integrated components to solve for data needs of generative AI applications. We understand how crucial this piece is, and we're introducing several key capabilities with this release in developer preview. We have the Docklink container image built with the Docklink package in our Python index, and Docklink models are made available on Red Hat AI Hub on Hugging Face that Rob just covered. And this matters because these features provide a critical Red Hat scan runtime image for your Kubeflow pipelines that you can start building to orchestrate some of these workflows. For RAG applications, for data processing, for just general structured data extraction, and so on and so forth. The way to use it is that you can install the Docklink package directly from the relevant Python index using the Red Hat AI base images, or you can use the container image available on registry.red.io as the runtime image as well. Finally, over the next quarter, we continue to work on more examples on how to do distributed data processing with KubeRay and Ray Data and the Kubeflow Spark operator, and providing performance insights on how you can just structure these better. Another key capability here, and this time focused more specifically on batch processing of large data sets, especially for AI workloads, is the Kubeflow Spark operator. This is also being introduced as developer preview in this release. With our next release, it will be installed with the roads operator itself, providing a zero-touch install experience. And with this, we plan on supporting the deployment and the management of Spark clusters on OpenShift AI, while allowing customers to bring their own Spark runtime image. Over the second half of the year, our goal is to just make it easier for users to connect to databases, to applications like SharePoint, Confluence, to drive the Kubeflow Spark operator to tech preview, and help answer questions around what happened to my data once I brought it onto the platform with some data lineage capabilities. Next, I'll hand it over to Aditi.
Awesome. Thanks, Jill. So I'm going to talk a little bit more about what's new in the landscape for synthetic data. We had introduced synthetic data generation for model training, and we have moved beyond the model training use case, synthetic data for RAG evaluations and multiple other use cases. So one of the biggest bottlenecks in building production-ready RAG applications is not retrieval or generation, it's evaluation. Creating high quality evaluation data sets manually is expensive, time consuming, and it breaks down every time your knowledge base changes. With Red Hat AI 3.3, we are bringing SDG Hub synthetic data generation capabilities directly into RAG evaluation workflows. So AI engineers can now automatically generate grounded evaluation data sets covering relevancy, faithfulness, and semantic similarity, using the same documents their RAG system is built on. This means you can adopt eval-driven development for RAG from day one. No more blocking on manually labeled data before you can measure whether your chunking strategy or retrieval method is actually working. It's as simple as pointing the RAG evaluation dataset flow at your input documents, calling the flow.generate, the concept of flows with an SDG hub, and getting a ready-to-use dataset back. You can find the reference notebook in the SDG Hub repo. The link is right here in the slides. The bottom line is this is fast iteration, earlier detection of retrieval versus generation failures, and a clear path from POC to production for enterprise model customization. Moving on, In 3.4, we are expanding SDG beyond RAG evaluation to high-value enterprise scenarios. First, tool using tuning data for MCP. As enterprises build agentic applications on top of their custom MCP servers, they need models they can reliably call the right tools at the right time. We are adding SDG flows that generate domain-specific training datasets for exactly that. So you can fine-tune your LLM to be a reliable tool caller against your specific APIs and workflows, not just generic benchmarks. And this domain-specific tool calling MCP data can also be used for evaluating your agentic setup. Second, adversarial safety data. This is a big one. Enterprises deploying models into production need confidence that their guardrails hold. We are enabling teams to generate red team and stress test datasets grounded in their own responsible AI policies, covering jailbreaks, misuse scenarios, and data leakage. This directly connects to the effective safety context window research we have been tracking. And looking further out in the second half of 2026, we're connecting all of this into our auto RAG workflows, which Suhas is going to talk a little bit more about, and Jalem already covered and introduced auto RAG. So synthetic evaluation data feeds directly into automated RAG optimization, and we are extending SDG to generate evaluation test sets for agentic systems, which is the next frontier as customers move from RAG into full agentic applications, as we are not just in a few years of agents, we are in the decade of agents, and we need to keep the agents on the leash, so evaluations are important. So the common thread here is simple. Synthetic data becomes the control plane for how you tune, evaluate, and harden your AI across every stage of the life cycle. Moving to the next slide, let's talk about what's new next for Training Hub. In 3.3, we are shipping 3 meaningful updates. First, we have added support for LoRa and QLoRa with Onslaught as the supported backend within Training Hub. This gives teams highly memory-efficient fine-tuning that's significantly faster without sacrificing quality. It's particularly impactful for teams working with limited GPU resources. And Onslaught is a reliable backend, and you can run it in a supported way on Red Hat Stack now, because we manage all the dependencies for you within the Training Hub package, which is a supported package available on the Red Hat Python index that Jalem was talking about. Second, we are adding continued pre-training or CPT algorithms. So this is for teams that need to go deeper than instruction tuning, injecting domain-specific knowledge directly into the model's weights before fine-tuning for a specific task. We have added support for that as well through Training Hub. And third, and this one is important for enterprise teams, we have introduced a minimal training AI pipeline. So instead of stitching together custom scripts for every training run, this gives teams a governed end-to-end workflow that standardized fine-tuning, evaluation, and model registration in one flow. So this is less glue code and more focused on the actual model work, and you can run it in a stable way on Red Hat Stack using AI pipelines or Kubeflow pipelines approach. Moving into 3.4, we are making Training Hub as a first-class citizen in Red Hat AI, seamlessly integrated with Kubeflow Trainer v2 and a universal workbench image. Think of this as a validated way to run training on your enterprise stack. Further out in the second half in 2026, we are adding a customizable entry point from AI Hub, making it easy to kick off training directly from our platform. We are bringing reinforcement learning as well with verifiable rewards as our supported algorithm in Training Hub, which is key for reasoning model development and for agentic AI. We're also introducing a conversational AI experience for model training through our new projects, lowering the barrier for teams who don't live in notebooks every day. So we're targeting different personas and new experiences for model training using conversational AI. So Training Hub goes from a standalone library to a fully integrated governed training platform. Moving on to the next slide. So we are also introducing a new feature. JLM already introduced AutoX features. We're introducing AutoML in Red Hat OpenShift AI. Not every AI use case requires a large language model. Enterprises still have a massive number of predictive intelligence workloads, customer churn, fraud detection, demand forecasting, risk scoring, where classical ML delivers faster, cheaper, and more explainable results. The challenge has always been the complexity. Building a production-grade ML pipeline requires feature engineering expertise, hyperparameter tuning, model selection, and rigorous validation. That work is slow and it requires specialized skills most teams do not have in abundance. With AutoML in Red Hat AI, powered by open source AutoGluon libraries, we are automating that entire workflow. You bring your data set, define your prediction target, and the platform takes it from there, running multiple algorithms across a range of hyperparameter configurations, evaluating them against metrics like F1 score, ROC curve, and giving you the confusion matrix, and surfacing a ranked leaderboard of the best models for your specific use case. So the result is that data science spend less time on problems that matter, data scientists spend time on problems that matter and less time figuring out the glue code, understanding their data and their business, rather than on building custom scripts or pipelines. This continue to build in our vision of a unified experience where whether you are fine-tuning a large language model or a predictive machine learning model, Red Hat AI guides you to become to the best outcome with least friction. And in our roadmap for AutoML, we're also gonna be giving support for exposing a predictive model as an MCP tool so that you can plug it into your agentic systems, because predictive AI and generative AI will work hand in hand when people start building agentic systems. So AutoML is gonna improve our time to market. It's easier to operate in ML or PhD required, ready to use for citizen data scientists. I'm going to hand it off to William to talk a little bit more about our eval-driven development story with Evaluation Hub.
So AI is no longer experimental. Teams are building models, RAG pipelines, agent, and full applications, and moving fast. But there's an uncomfortable truth. Most of the teams are just flying blind, and the dominant approach is still demo-driven development, meaning iterate until it looks good and ships one stakeholder's kind of nod. Well, there's a better way. And the solution is known. It's called evaluation-driven development, where you start by defining the success criteria before even writing a single prompt. Okay, so Eval Hub is our comprehensive evaluation platform for AI systems all across. Now, in the first half of 2026, the capability focused on evaluating models, RAG system, agents, and full AI applications using popular or custom frameworks. We benchmark both performance and safety, assessing models and guardrails against risk criteria, for example. Need to evaluate agentic systems? We assess capabilities like autonomy, tool execution, and reasoning quality. One relevant benchmark for your domain? We provide industry-specific test suites or collections for healthcare, financial, and more, ready to use out of the box. Coming in the second half of 2026, we'll have automatic evaluation generation from your production LLM traces. Segmented analysis that gives you actionable recommendation, like which guardrail to adjust or which model to switch to. And reference notebooks for visualization of or analysis of the results. How to use it? Well, 3 paths right now. A REST API with full docs at the URL that's shown here. There's a Python SDK. It's just a simple pip install. Or in product, the Red Hat AI Evaluation UI, coming in 3.4 for a no-code web interface experience. So this is what's coming with Eval Hub. Now I leave you with Suhad.
Thanks, William. RAG still powers a lot of GenAI use cases in production. So as most of you know, RAG is very powerful, but it's notoriously very complex to optimize, right? So our auto-RAG capability aims to automate that process. Instead of manually guessing the best chunk size or embedding model, AutoRAG runs automated pipelines to test multiple algorithms and techniques for the specific data set. It performs hyperparameter optimization across variables like vector stores, top tier retrieval settings, etc., and then evaluates the results using advanced metrics like faithfulness and answer correctness. This shifts the work from tedious manual testing to automated optimization, and hence allowing your team to move from a very simple raw data set to high performing RAG pipeline in minutes instead of days. So we are targeting a tech preview of end-to-end user experience and notebook experience of AutoRAG pipelines for 3.4. And in the roadmap, we are looking at advanced context intelligence. We are looking at evaluations at each step of RAG pipelines and features like agentic RAG, graph RAG, multimodal RAG, and many other RAG kinds of techniques later in the year as well. Thank you. With that, I'll pass it over to Gustav.
Thanks. I'd like to go a little bit into our training domain, right? As you might know, we are supporting Kubeflow Trainer and RHEL training. We have had a huge update on the Kubeflow Trainer framework, moving from 1 to 2, also supporting version 1 so that you have a smooth migration path. Now I want to focus on the checkpointing feature itself that we would like to provide for both of these frameworks. Checkpointing, I've talked about that in the last What's New, What's Next session, is very important if you have long-running training jobs, for example. If you're trying to utilize your GPU infrastructure to a maximum, it might be that you have higher priority jobs, that you have lower priority jobs. It might even be that you have failures in your infrastructure. All these situations are one of the reasons why we are integrating the checkpointing features into our product. Imagine that a job fails, simply dies, and you don't want to recalculate the hours that you have invested before. You want to fall back to a checkpoint. You want to resume at a specific point in time in the training. That is what we are enabling with the checkpointing in the Kubeflow Trainer, PyTorch, and in the RHEL universe. If you have a close look at the slides, it is related to specific versions. So it's on early access 1 and 2, and later on 3.4 when we're going to release these features. As I said, keep in mind, high priority jobs might evict low priority jobs. There might be failures in your infrastructure. Keeping the investment, not letting all the data go, is very important here. Interesting feature is that, for example, in Kubeflow Trainer, you have your PyTorch job up and running. You can checkpoint at a certain point in time or after an amount of epochs that have been calculated. And our platform will save the checkpoint file. And if you think about a large distributed training job, there might be a lot of data that you need to store. We're going to save them very fast to disk and later on transfer them to an S3 or a PVC. This is like a staged storage management for the checkpoint files themselves. Cool. So this is one of the features I want to highlight. Keep an eye on the checkpointing for Kubeflow Trainer. On the next slides, I'm going to go into more of our topics. Ray training, checkpointing, I talked about that. There's another quality of life thing we are doing, providing to our data scientist community, that is OpenID Connect. We're trying to move that into each and every of our components. So basically logging into the cluster with your Jupyter Notebook or with your training job or with your Ray data processing gets a lot easier. This is quality of life that we're doing. We are looking for MLflow integration later on for experiment tracking. We're going to hear a little bit about that later on. And we are looking for moving our capabilities a little bit closer to the high-performance computing domain. We've heard that early on, high-performance computing with ROCm or ROCI, and we are looking if we can integrate the MPI jobs into the Kubeflow trainer and other high-performance computing capabilities. So if you have customers, if you are a customer interested in high-performance computing, please let us know. That's a very interesting topic. Moving these two kinds of workloads, AI, training, fine-tuning, and HPC into the same infrastructure. Also, we are looking, as I said later on in the what's next section, at the integration of the RHEL dashboards, so integrating more and more observability features into our platform. And that's it from my side. I'm gonna move on to the inference timescaling. Thanks.
Yeah, thank you. So today I wanted to give a quick update on our inference timescaling work. At a high level, ITS provides techniques to improve model accuracy and reliability at the time of inference. This is especially important with the rise of agentic systems, where reliability is not just a nice to have. If a model misses a tool call, chooses the wrong tool, or fails to follow a required sequence, it can cause the entire workflow to break. These techniques work by allocating additional computation at inference time through selection, verification, or search-based strategies. This is all to improve response quality without needing to modify or retrain the model. You can go to the next slide. Currently, these algorithms are available as an SDK, which is included in the Red Hat AI Python index. And now upstream, ITS is also available through a gateway. That matters because it lowers adoption friction and allows non-Python clients and services to benefit from ITS as well. In practice, the gateway sits in front of inference and lets users configure algorithms and parameters per request. That helps make ITS easier to adopt across a wider range of services. Looking ahead, our plan is to roll this out in phases. We are targeting a tighter integration with our current Envoy solution, with the longer-term goal of integration with the Red Hat AI Gateway. The aim is a more seamless experience and better integration across our platform. Now I'll pass it over to Adil to dive into AI agents.
All right, thank you, Luke. So we took an interesting journey to get here, right? And we're standing on the shoulder of each of the other pillars that Jeff mentioned at the beginning. So we've talked about inference, fast and flexible and efficient inferencing. We talked about how you can connect models to data. And now we're going to talk about agentic. And agentic, what's interesting about it, it depends on all of these pillars. We need efficient models for reasoning with agents. We need to connect models to data for agents to search. And finally, we need a lot more. So basically with agentic, a lot of folks have started the journey with ChatGPT and then moved over to chat completions and OpenAI, into APIs, and then the age of the frameworks, and now the age of the harnesses. The top layer is changing rapidly. It's becoming fungible. Our goal is, regardless of how you get started, whichever framework you use, whichever harness or coding agent or agent you use on top, we give you the foundation to operationalize all of this and gets us to production. And we're doing this in different ways and shapes and forms. I'm not going to talk much about models, but you've heard about the model gateway and MAS, model as a service. What we're building in addition to that is we're looking at the industry conformant APIs, which APIs are winning. And we're going after the winning APIs and implementing those as part of the product. One of the winning APIs for agentic is the responses API. And so recently, OpenAI actually made that open by introducing the open responses spec. This allows people to implement that spec to comply and allow any agent or any harness to actually call out to that. And with Red Hat AI, we're building this implementation to allow you to point your AI agents and runtimes into self-hosted or even hybrid models. And we're doing that today was Llama Stack. And in addition to that, Llama Stack bridges into different other functionalities. There's also the MCP gateway. That's a different layer. We're going to be talking about that. But the idea here is agents make calls to tools, how do you govern these tool calls to agents? How do you provide the right foundation for tool calling and introducing the security layer on top of all these other API servers? And with all of that, we want to make sure that we provide a nice operational layer. So we're going to talk about that right now. Next slide. Right, so our goal at the end of the day is to provide a unified approach for our customers to manage the full life cycle of agentic, from security, performance, to deployment, to production. It matters because we want to provide the operational rigor. So many people are starting from their laptops, but they're getting stuck on how to get this agent that I just experimented and deployed reliably to production and provide the life cycle and deployment mechanisms for this agent to work reliably and securely. And what we're doing with Red Hat AI is we're looking at how can we do that. And it goes on to different layers, from observing, tracing, and evaluation. William talked about evaluation as an important piece of the stack. In addition to that, we're going to operationalize that, first starting with tools like MLflow, providing the foundation for getting traces in and providing evaluation and scoring mechanisms, all calling from using Eval Hub and APIs from Eval Hub to consume that. In addition, we want all these traces to be OpenTelemetry compatible. So yes, we're starting with MLflow, but it doesn't end there. Any OpenTelemetry compatible sync should also be possible to integrate with and expand into the future. In addition to observability, tracing, and evaluation, and providing the foundations for those at runtime, we also are providing the security and identity layer. We know agent and LLMs are stochastic. We know that semantically they can do a lot of things that are unguarded at runtime. So we want to make sure that each agent action is governed. We want to make sure that tokens that agents use at runtime are scoped correctly, especially when calling out to external API services, other agents, or even MCP servers or tools exposed by MCP servers. And finally, we're actually repurposing cloud native to agent native. We're using the same tools and deployments that we have with OpenShift, had and have with OpenShift, and we're providing tooling on top using the GenAI project, which we're going to be productizing to manage the agent lifecycle, providing an agent runtime abstraction to inject all the necessary identity, tracing, security mechanisms into your agent without you having to change as a developer anything to your agent. And finally, we want to make sure agents are safe. We want to provide the right guardrailing foundation. We want to provide the right red teaming foundation such that before you even get to deploying your agent to production, you have the right levels of confidence to make sure to inform the decision of like, hey, this agent is ready. Other people can consume it. Next, I'm going to hand over to Peter to talk. Oh, actually, yeah. So just covering over our agentic roadmap, just real quick. I think I talked about high level, like the different pieces of the stack. So with 3.3 and 3.4, a lot of things are coming. So with 3.3, Llama Stack keeps expanding the different provider interfaces that we have, especially with vector stores that we're implementing in addition to open responses as part of Llama Stack and the responses API. There's other supplementary APIs like file search and vector stores. Quadrant and PG vectors are coming, PG vectors specifically is in the documentation. You can check that. So we're being compatible with different API and RAG databases. In addition to that, we are TPing in 3.4 the responses API tech previews, which will also provide more and will pop up in the documentation and will provide more examples and stream starter kits and templates of how to use the responses API with your agent framework, regardless of where they come from. And there will be also support with GPT-OSS for tool calling, which we also talked about with VLLM, but Llama Stack is going to be consuming that. And we're going to be targeting parity with the open responses spec. So the open responses spec is going to keep moving, and we're going to have to keep moving as well in parity to make sure that the implementation in Llama Stack is compliant. We're also going to depth review the agent lifecycle mechanisms with Kagenti. This starts with providing a discovery mechanism using the agent card, so you can figure out and discover from any interface which agents are running and how to communicate with them. that is based actually on the A2A discovery mechanism. And we're going to be providing the rigor of security and access control using token exchange and tools like Auth-Bridge. And later, second half of the year, we're going to be working on Asian catalogs as part of the AI Hub, AI Hub UI, as well as the Kagenti integration of that. And then we're also going to be starting to evolve Kagenti as tech preview as part of the product and work through our Asian registry implementation. In addition to that, we've talked about operationalizing agent. We know that sandboxing is becoming more and more important. So providing means to configure sandboxing based on the primitives exposed to us by the OpenShift platform will be very important, and we're going to be focusing on this as well. And governing the cost, not just the security and the operational aspects of agents, looking into how to integrate with OpenShift cost management or Lightspeed cost management, and providing the primitives for agentic, be it models or tools or MCP servers, is something that we're looking into. And finally, expanding Llama Stack to be able to configure it at runtime and add specific configs at day two, not necessarily at build time. Right, now we can go next, and we can go to Peter. Thank you.
Hello all, and we're building a full MCP platform stack now, not just connecting tools, but governing and securing them at scale. In collaboration with the OpenShift networking team, the MCP gateway is in dev preview. It's Envoy-based, sits in front of all your MCP servers as one endpoint, and adds 3 security layers. Identity-based tool filtering, so users only see authorized tools. OAuth 2 token exchange for scoped per backend access, and Vault integration for non-OAuth backends. The MCP catalog is also coming, a curated storefront for MCP servers in the OpenShift AI UI. With OpenAI Responses API, we've added per server MCP authorization. Agents configure credentials per tool server with no cross-server leakage. Sensitive tool calls go through an approval workflow now. This complements the gateway. Platform enforces access, application manages credentials. Upcoming as well is the MCP deployment operator, which is going to handle the full server lifecycle on OpenShift. So the end-to-end flow: browse the catalog, deploy, gateway auto discovers, agent calls tools with per server auth. Gateway enforces identity and token exchange. Approval kicks in for the sensitive actions, and you get full MCP governance. Next, please. This slide is simple. This is all about the timing of the items we just discussed. In 3.4, we delivered the foundational pieces of the developer preview. MCP catalog integrated with Kubeflow, MCP deployment operator as an OpenShift SIG solution, and MCP gateway integration via Envoy Istio extension. That gives you discovery, deployment, and enforcement starting to come together. Then in the second half of 2026, we mature the control plane. MCP registry for governed server tracking, MCP gateway registration UI for simplified onboarding. So 3.4 brings the core building blocks online, and the second half of 2026 makes it enterprise ready and easier to operate at scale. GenAI Studio is also rapidly evolving, and what's coming over the next 2 releases we'll talk about in the next slide. So with Red Hat 3.3, it's all about making the playground feel in control. This release is about tightening the feedback loop with MCP tool toggling, allowing you to turn off specific tools instantly with no friction, no redeploy, just experimentation. Then we also are adding stop the ability to run chat, of course, killing long running sessions when they go sideways. New chat sessions reset cleanly and move you faster. This is about control and speed when you're iterating, because these seconds matter. In Red Hat AI 3.4, we're going to be delivering a big playground update. This is where we really step it up. Full playground UX rework inspired by the Watson X AI Prompt Lab experience. Cleaner, workflow-driven, built for how AI engineers actually think. Multi-instance chat comparison. We're going to be able to run A/B tests side by side, comparing models, prompts, data strategies instantly. And then prompt engineering and management powered by MLflow will treat these prompts like real artifacts. Guardrails and existing vector store surfacing bring safety and context into the visible workflow. And the external LLM endpoints, which of course we're excited about, will connect you to the models you need wherever they live. This is where experimentation turns into structured engineering. Now, what's next for the second half of 2026? In the second half, we're really going to be focused on configuration persistence and deployment. So this is about saving entire setups and deploying these from Playground to sandboxes and namespaces intentionally. Also, we're going to be adding tracing with adding clear observability of what is happening behind the scenes. Inference timescaling, which we've already discussed, is also going to be surfaced, where you'll be able to tune those reasoning levels and performance characteristics intentionally. This is all about moving the playground to platform. Faster loops, stronger guardrails, better experimentation, and a clear path to production. I'm going to hand it back to Adel now, actually.
All right. Thank you, Peter. So we're going to continue with AI safety. So we've talked a lot about agentic and how we want to take agents to production. And to be specific, in the age of the clause, we're seeing a lot of increased interest in AI safety. Mainly, safety is becoming a blocker for taking agents, models to production. So what are we doing about that? We're basically providing a portfolio for safety to detect, test, and mitigate risks, be it bias, hallucinations, or even adversarial attacks, before they reach production, as well as guard against these potential runtime threats leaking into production or leaking into your runtime with the proper guardrails applied to your deployment. This matters a lot because enterprises need trust. That's actually the main blocker for agents and models getting to production, especially in generative AI. So you want to give enterprises the trust and the level of trust needed to ensure their AI remains compliant with the regulations and protects the brand of their companies from reputational and legal risks, especially when it gets out and be consumed by other users. So what's planned for the first half of 2026 is guardrailing mechanisms with NEMO guardrail. So we've been working on the foundation. The guardrail orchestrator has been GA for quite some time, which provided a strong foundation for based on demand, which will provide more real-time and inline filtering of toxic or bias or hallucinations, and an orchestration mechanism to combine all of this together. And we're going to be targeting GA post 3.4 or 3.4 actually. In 3.3, we're going to start rolling out starter kits. So in addition to the documentation that you get, you're going to get also tutorials and demos on how to consume the safety primitives. This will be shipping as of 3.3, and we're going to be expanding those post 3.3 and moving on. With 3.4, we're also, you might have heard about the Chatterbox acquisition. The Chatterbox acquisition brings a lot to the product, especially when it comes to adversarial vulnerability scanning. Before you even take those models to production, you would like to know or diagnose them for potential vulnerabilities and issues, for jailbreaks, for prompt injection. So the Chatterbox stack is going to be infused as part of the Red Hat AI stack through Garek, which is also going to be part of OpenShift AI and through the Trust AI operator. And also we're going to be consumed through Eval Hub and Kubeflow pipelines as part of 3.4. And finally, as of next, we're looking into how to model risk and expose risk as a presentation layer for our model catalog. This will be important to inform decisions about which models should be used for which use cases and which models are ready and safe for consumption. With that, I'm going to hand over to Miriam to take us through the platform.
Thank you so much. So what's new in experiment tracking? As you know, with all of these amazing new capabilities for agentic AI, it's very important to have a software engineering driven way to enhance our models, agents, or other assets like datasets, MCPs, and whatnot. So in Red Hat OpenShift AI 3.2, we introduced MLflow as dev preview. We have MLflow available both for predictive and GenAI use cases. And we are focusing right now on experiment tracking to make sure that any improvement or any baseline can be efficiently tracked with a very nice UI inside of Red Hat OpenShift AI. We are collaborating with the MLflow community, and we added multi-tenancy support. And we are also working on hardening and enhancing the performance of our MLflow distribution. Why does this matter? Well, we realize that most of our customers are doing AI and they are using already MLflow, but they are looking for an alternative that is on-premise and that can help with their sovereign AI initiatives. So now it's available in Red Hat OpenShift AI in a native way, meaning we are not only productizing it, we also integrate it with the operator. So no more headaches to install it, make it run in a Kubernetes native way. We have taken care of all of that pain on installation and operations. And then also we know that MLflow, it's a powerful tool, not only for experiment tracking, but we are taking an incremental approach here. Right now, we are very focused on connecting all of these different pieces, evals, prompt engineering, model training, connecting data to models to experiment tracking to have these visibility and observability. But later on, we also want to focus on agent observability, agent ops. We just want to go step by step. So what you can expect is that we will continue to harden MLflow to make sure that it meets all of Red Hat security and quality standards. And then once it's GA, we will start connecting the rest of the platform. Please go to the next slide. So our current roadmap includes having some more performance enhancements based on some customer feedback, hardening and security features for our MLflow distribution, preparing it to GA, coming for 3.4, and then having some UI modular architecture enhancements so we can integrate MLflow and all of these observability capabilities into the life cycle of an AI asset with the added capabilities that we have inside of Red Hat OpenShift AI. 3.4, we will have MLflow GA. We will have, and this is where all of the other integrations are coming. So we will integrate it with workbenches, so customers can easily send back all of their metrics to MLflow without having to worry about credentials or finding the URL or any other kind of like operational information. We will also integrate it, more importantly, with AI pipelines, because we know that one of the most important pieces is automation. So everything has to flow through pipelines in an automated way, in a continuous way. So here will be very important to use MLflow as an alternative backend for experiment tracking. And we will also integrate it with things like distributed workloads and the new KF training version number 2. Because again, the most important thing that we are seeing is that we want to have a unified experience. It doesn't matter in which part of the life cycle of the asset our customers are. We want to meet them there and give them all of the capabilities out of the box to send the metrics back to our experiment tracking service without any friction and seamlessly. And then finally, also, we want to integrate with the model customization component. So as you heard, the new Python index has a lot of very useful libraries to do model customization, to connect model to data, to generate synthetic data generation. All of those capabilities will be utilized and will be exposed through specialized components built with pipelines. And those components will also be out of the box instrumented, so they send the metrics back to our experiment tracking service. What's next, and we are already exploring it, but we will probably productize it later in this year, is agent ops with MLflow, and also the integration of things like evals and guardrails, maybe even responses also to this continuous flow of experiment tracking. Next slide, please. So the other component that will also be central to automating and productizing AI assets in managing the lifecycle with all of the rigor of software engineering is AI pipelines. So what are we launching now? It's AI pipelines reusable components. We have heard from customers from a long time that once they have a pipeline that they they have really curated and they have really invested on for a certain specific task. Could be like data wrangling, model tuning, whatever it is. They would really like to use it like a standard or a golden pipeline. So now we are providing that as pipeline reusable components. It's an open source repository. So we invite all of our customers and regular users of Kubeflow pipelines to contribute to this repository. Right now it is upstream, but we will probably look for ways to support it since it's central for our model customization and tuning. So we want to continue building momentum on the Kubeflow community. We are adding, like I said, a very rigorous process to contribute these reusable components and allow others to benefit from the things we've learned. And then we have a new Kubeflow project in Red Hat. Now with the Kubeflow project in the Red Hat OpenShift AI, we'll have a unified UI. So both the community and the product will have the exact same look and feel, the exact same UI. So that will save us from duplicating efforts on fixing things, and will also give the users and customer more consistent feeling when they use one or the other. Next slide. And for what's coming, right now for Studio 3, we are working on a lot of enhancements of AI pipelines. Like I said, because we are now adding support for MLflow as another backend for experiment tracking, we really had to make pipelines very modular. So pipelines will focus only on automation, and they will interact with that experiment tracking service. We are also working on enhancements on pipelines to be able to support more databases, to support different backends and storage for S3, and give our customers the ability to run pipelines locally. But to do that, we have to first enhance the whole technological stack. So what's coming in 3.4? Well, the pipelines integration with MLflow that we already discussed. Some UX enhancements for experiment tracking and comparison. We know that not everybody using pipelines are really managing the whole life cycle of assets. Some people may just want to use the default metrics comparison capability. So we want to provide a really good experience on that. And we are also going to enhance the way customers interact with the artifacts that were generated while executing a pipeline. What's next? Well, next, we want to use pipelines for continuous evaluation. We will also probably use pipelines for security aspects. That, security is really about running continuous checks and balances and evaluations and constantly monitoring our assets. So all of that is a pipeline that is constantly running, so we could leverage them there. And then also some UX enhancements of pipelines, as well as, like I said, support for things like Postgres SQL that has been a request from our customers for quite some time now. And with that, I think I will pass on to Kezia, and thank you so much.
Thank you, Miriam. Hi, I'm Kezia Cook, one of the PMs working with the Feature Store and Workbench teams. Feature Store has officially gone GA in 3.2, and with this comes improvements to ensure usability in RHOAI and its relevant components like dashboard, workbenches, pipelines. So for the dashboard, Feature Store is able to directly access workbenches to browse features, test queries, run pipelines, and this will all be visualized alongside the amount of instances with connections to statuses and RBAC permissions. So additionally, these enhancements will allow secure data science workflows across multiple Feature Store development environments. And then these enhanced capabilities will allow users to stay in their permission development environments with no context switching or worry of unauthorized access. And to explore and launch a workbench in the Feature Store connection, it'll appear on the dashboard side of the navigation bar. And then there will be you'll be directed to browse the feature catalog to preview the data, copy code snippets, and just look for feature retrieval. And the users will be associated with connection status indicators like connected, error, unavailable, to show the health of the workbench and gain guidance on how to proceed from there. Next slide. And then next, additionally, with the feature store updates, RHEI will now be supported as a compute engine and an offline store. So RHEI will allow users to have distributed, scalable feature engineering pipelines using data processing and orchestration. So this will also allow for users to use RHEI for embedding generation, deep learning processing, or pre-processing in RAG. And then with this support, Feast may be leveraged as a plugin for end-to-end ML pipelines for the RHEI ecosystem. And to run a RHEI pipeline, users will just need to update the pipeline to include a RHEI cluster image, create a connection between object storage and their wanted data science project. And then when this is complete, they'll be able to configure and schedule this run. There's additional documentation in Feature Store's upstream solution Feast to learn more about utilizing RHEI as a compute engine as well. Next slide. And then alongside RHEI, we have Spark support. Feature Store now allows Spark infrastructure for transformations, and this will allow users to generate data sets, materialize clean features for offline and online storage. This will save time for customers who perform batch processing and real-time jobs. So Spark supports a wide range of data sources, transformations, promoting multiple plugin options to handle these big data loads. So listed in the slide, there are resources on how to use Spark as a compute engine and offline store. So there's additional information on how users can configure and define Spark as well with EML objects. Next slide. So in the first quarter of 2026, Feature Store was able to go GA with RBAC, workbench integration, and usability improvements in the dashboard. So for 3.4, we are targeting feature monitoring to track distribution and quality metrics. In the next phase of workbench integration, that will include more visibility and performance optimization. So what's next involves real-time drift detection and alerting advanced governance and extended lineage. Next slide. So for notebooks, with the help of AI PCC, RHOAI notebooks will inherit new base images and will collections for our out-of-the-box workbench images for customer usage. So these images will reduce the duplication of available notebooks that are already existing, increasing security while decreasing the amount of CVEs in customer environments and streamlining that maintenance. So to use these images, customers will be directed to follow the same workflow to gain access, which is found in our notebooks catalog. And next slide. So in 3.2, the AI PCC-based images have begun the migration process for customers to use. And this has also been the same for 3.3. So for 3.4, there will be notebook enhancements as well to update the notebook binaries. We have different packages and libraries for the out-of-box workbench images. And the official set of AI PCC images and wheels will be available for use. So users will have that migration path as well as we adopt these new images. And in the second half of the year, we'll be focusing on the Build Your Own Notebook initiative for users to customize their IDs to their IDEs to their specific needs. So we are targeting to include GenAI Jupyter extensions as well to improve the overall Jupyter Notebook experience with integrating LLMs, generating code, and summarizing content. Next slide. For the notebook server team, who's also working with workbenches, is working in the upstream space to focus on bringing new functionality to RHOAI. So currently the goal is to enable admins to have centralized control for configuring and editing environments. And this will allow dynamic updates and editing privileges in user environments without pause. Admins will gain better insight into workbench status while handling and ensuring improved GPU management, configurations, and will allow for more flexibility with updated and bug-free images. So as this is community work, we will be providing updates on how to use this functionality in upcoming releases, but the team is working in the upstream spaces of Kubeflow to make sure that these changes are made and get the stamp of approval before moving downstream. Next slide. So as of today, there is previously mentioned the upstream, we're calling that the Notebooks 2.0 work in the Kubeflow community. In 3.4, the target is to release Notebook 2.0 as GA in the community and then release Kale pipelines as well as GA, which is the new addition of Kubeflow pipelines in full integration with RHOAI. In the second half of the year, the target is to have an interactive platform catalog with notebooks for specific use cases, enhancing the overall workbench usability through the Notebook 2.0 initiative, and deepen the integration between RHOAI components like pipelines. And from here, I will be passing it back to Jeff, I believe. Thank you.
All right, thanks, Kazia. Okay, so next, let's talk about observability. With the current release, we're providing a centralized platform for AI metrics to keep all performance data really in one place. Starting with the setup, it's zero config. The cluster observability operator deploys a centralized Prometheus instance that captures metrics across all OpenShift AI components, so there's no manual configuration required. For the visualization, we're providing reference Grafana dashboards for two personas. Cluster admins get visibility into GPU and hardware utilization, while data scientists can track model-specific metrics like latency and token throughput. You can access this data via the Prometheus API or by connecting it to existing enterprise dashboards. This centralized approach ensures that monitoring remains consistent as workloads scale into production. Okay, the observability roadmap really focuses on making platform metrics more accessible and specialized for AI workloads. For the 3.4 release, we're adding native foundational dashboards in OpenShift AI. We're also providing mass observability as part of the overall Model as a Service GA release. For GPU as a service, we're providing metrics that give teams visibility into queue status and scheduling so they can monitor and optimize compute utilization. For agents, as you've heard, we're starting with ML flow tracing in 3.4 and expanding to full distributed tracing for multi-model chains and tool calling in the second half of the year. Also, for second half 26, we're planning to introduce GPU health monitoring to handle hardware level fault detection and automated recovery. So overall, this moves the platform from basic metrics to native visibility across the model and hardware layers. Okay, we'll pass it back over to Christoph.
Yeah, thanks. I just want to point out another very important aspect of the GPU as a services. As we have heard it, we're trying to increase the load on the GPU infrastructure that we have invested in or our customers have invested in. We're investing into the observability aspects of that infrastructure, and we are also investing in the workload scheduling and the partitioning or the fractioning or the slicing of the GPU infrastructure. So you know that, or you will hear about that new GPU devices come out, which are larger and larger. And envisioning the data scientist sitting on a very large GPU is not the best investment. We are following the technology that is partially available on the upstream and the Kubernetes upstream projects to partition devices so that we can assign half a GPU, quarter of GPU to a data scientist notebook. So that's what's coming up in the GPU as a service realm in the next half year, in the second half year of 26, adding to the lower level of the infrastructure on the GPU as a service domain. And that's it, just a short shout out, and we are moving on to the next slide then.
So zooming out to connect these features, at Red Hat AI, our continuous stack and feature growth is focused directly on the end-to-end challenges of operationalizing AI. And this is what we call the jobs to be done. We address the full lifecycle grounded in direct conversations with customers and industry professionals. So each addition to the platform maps to real-world production challenges that you'll face. Next slide, please. In 3.3, we focus the dashboard experience on the moments team hit most often. So serving models through mass, discovering and reusing assets on AI Hub, iterating in GenAI Studio, and tracking progress with ML Flow experiment tracking. The 3.3 UI release blog is linked above with short demos on how to use these features in practice. Next, please. Next, please. As AI flows on OpenShift AI become richer, access control can become a bottleneck. Teams need to find the right people to do the right tasks without opening everything up or sending every request to platform ops. So in 3.3, we made it easier for non-admins to see what they can do and for admins to assign more targeted permissions. And we are building towards a full self-service granular role creation in 3.5 and second half of the year. So stay tuned. Next. In 3.4 and beyond, we're strengthening the mass admin workflows with clearer quota visibility, self-serve API keys, and streamlined quota assignment. We're also introducing a new evaluation UI, as mentioned by William, so users can launch Red Hat AI curated evaluation collections in just a few clicks, alongside new observability for cluster and VLLM metrics, and a smoother experience for data connections. And in the second half of 2026, we'll be focusing on improving the flow to getting started on OpenShift AI by connecting the tools offered by our platform in a visually guided experience to streamline our time to value. Now, I'll pass it to Suhas to talk about a new way to interact with our platform with Project Navigator.
Thanks, Jenny. Let's talk about Project Navigator. This is a very exciting feature that we are building. Think of it as a decision support agentic AI system for your AI projects, right? So the idea is to make it super easy to go from a simple user intent like, hey, I need to create a RAG-based chatbot. Help me decide the most suited model in the catalog for this use case, right? To a real working AI solution. It helps you right from the start, taking your vague idea and turning it into solid runnable pipelines, complete with all the pieces you'll need. Because it brings together all our tools for checking models, deploying models, RAG, data, fine-tuning, security, and more, Project Navigator speeds up your whole AI process. So it aims to take the guesswork out of operationalizing OpenShift AI workflows so you can move from testing to production much faster. We are targeting a developer preview of 2 use cases for the summit timeframe. So one is the intelligent model recommendation, and the second one is optimized model deployment to begin with. And then we intend to move over to the other OpenShift AI workflows as well later in the year. So with that, I'll hand it over to Erwan.
Hello, thank you, Suhas. So I will cover the latest updates on accelerator support in Red Hat AI. So we are expanding the Nvidia partnership. So William introduced the new Red Hat AI Factory with Nvidia, which is a software platform that brings together Red Hat AI Enterprise on Nvidia Enterprise. And we are also announcing Red Hat on Nvidia 0-day support for the latest Nvidia architectures across all the Red Hat portfolios. So Red Hat AI support currently Blackwell architectures, and with Red Hat AI 3.3, we are introducing the support for the Nvidia B300 and GB300 GPUs. So VLLM is now leveraging CUDA 13, and you can use the most powerful GPUs with Red Hat AI. We are also extending the product support to the AMD Instinct MI325X GPU based on AMD CDNA 3. We are also introducing the first Red Hat AI Inference Server for CPUs. We start in tech preview with Intel CPU on AVX2. The next release will support Intel AVX 512 AMX. We are also proud, after a lot of work, to announce the tech preview support for AWS Inferentia on AWS Trainium, including support for Trainium 2 accelerators. So you can use OpenShift Self-Manage or RHOAI on AWS with your AWS Neuron operator. You can find this operator in any OpenShift. So you can run a VM or use OpenShift on AWS to now use the AWS accelerators. Next slide, please. So now let me share what's next on the Red Hat AI roadmap for accelerator support. So Red Hat AI 3.4 will add support for the new RTX Pro 4500. With ROCm 7 on PyTorch 210 support, we are preparing enablement for the MI350X and MI355X accelerators, so targeted for Red Hat AI 3.4. So this new generation of GPU based on the CDNA core. So we're also introducing new VLLM certified accelerator support with RHEL AI in Q1 and MetaX in the first half of 2026. Next slide, please. So now let's focus on the overall roadmap for Red Hat AI Inference Server. So we have reviewed the accelerators currently supported, the plan for Red Hat AI 3.4. So on the model side, Red Hat AI 3.3 has inference support for Mistral Large Tree and Mistral 3. With Red Hat AI Inference 3.3, we are proud to support Earth and Space Foundation models in production on the Red Hat AI stack. So this includes PRID-VEO models trained on the time series samples from NASA. And with PRID-VEO, you can run tasks like flood detection or landslide mapping. So the PRID-VWXC supports also weather and climate modeling. So it's not for every people to use this, but we have some demand, and it's great now to support these models on Red Hat AI. So you can find the full announcement in the blog post we published just a few hours ago on redhat.com/blog. So it's called Scaling Earth and Space AI Model with Red Hat AI Inference Server on Red Hat OpenShift AI. So with Red Hat AI Inference 3.4, we'll provide distributed inference with LLMD on over Kubernetes, as Naina was saying, targeting CoreWeave on Azure Kubernetes service first. And I will finish with what is coming in the second half of 2026. So we will support VLLM Omni models enabling unified multimodality text, so image, video, audio with any modality in and any modality out. We are also improving our Red Hat AI Inference VLLM support, introducing AMD Zen DNN support. And for our Nvidia partnership, we will deliver zero-day support for the Rubin architecture, including ARM Vera Rubin and x86 Rubin. With that, over to Jeff.
All right, thanks everyone. Okay, so this slide summarizes what we've covered so far, specifically for OpenShift AI in 3.3 to the 3.4 release in the summit timeframe and our high-level priorities for the second half of the year. I'm not going to go into the details here. This is really intended as a reference slide. So while we focus quite a bit on new GenAI features, we're also continuing to invest in maturing our predictive AI capabilities. This slide highlights some planned platform enhancements that further support predictive AI workflows. Many of these features are applicable across both predictive AI and GenAI workloads. To wrap up, here's a look at our release cadence and support life cycles. Starting with 3.3, we'll deliver GA releases once a quarter with 7 months of support, alongside monthly early access releases to get new features to early access customers faster. These early access releases are not supported and they're not intended for production. For organizations that prioritize longer-term stability, we provide one EUS release a year with an 18-month support window. Earlier this year, we introduced Red Hat AI Quick Starts, which are deployable industry AI use case demos designed to show a clear path from a baseline install to real-world outcomes. I'd encourage you all to read the blog for the technical details and then visit the homepage to see how they're built. They're great resources for learning the stack and proving out technical feasibility. For partners, we'd also encourage you to work with your partner account manager to develop new quick starts that we can feature on the site. Okay, and then this final slide contains a set of links for the material we covered, including our technical blogs and the arcade demos, which are great for seeing the platform in action. If you want to try the products, we offer 60-day trials. So that's all for this update. Thanks everyone for joining the session today.